Here is a review of essentially what we're working on over yesterday and today. The first page that you see here is a review of day one. There was a video over that, so I just wanted to kind of hit some high points just to make sure we're on the same page. Number one, we learned 5 formulas on day one, if you could call them that. The first thing we talked about was component form of a vector. Vectors are composed, a vector is this black arrow here. It has magnitude and direction. It has a force, a strength, a distance. All of those things can be considered magnitude. And it has a direction. It has an angle measure that it is rotated to based on the standard position from the origin. Now, when I talk about component form, I'm really looking at x and y components, horizontal and vertical components. You can see that written, here. If I have a vector like this, it means if I'm starting at this point and I end up here, then how do I get there using rectangular directions, left, right, up, down, east and west, or even north and south, right? So for this one, I would go to the right x units and I would go up y units, and that would be the components of that. If I start out with magnitude and direction, well, that means if I had the magnitude, the length of the vector, and I had the angle that the vector was rotated to, then I can get my components by just doing magnitude times the cosine of the angle for x, and the magnitude times the sine of the angle to get y. If I wanted to go back the other direction, if they had given me x and y to start with, if I have the actual components like this, how do I go backwards and get, or forwards, I guess, depending how you look at it, and get magnitude and direction? Okay, so that's where these formulas come into play. Magnitude can be written with single bars or even sometimes double bars. It means the same thing. It's essentially the Pythagorean Theorem. X squared plus y squared equals the hypotenuse, right? So I'm going to take the square root of x squared plus y squared. Now sometimes you'll see written as x and y. Sometimes you'll see it written as v1 and v2 for vector part 1, vector component 2, things like that, right? So just kind of take it one step at a time and kind of notice those two things. Okay, that's how I get magnitude. Essentially, how do you do the Pythagorean Theorem? You've always done this, right? That's nothing too crazy. Theta is my direction. At what point we're going to measure theta as if we're putting the vector itself at the origin. Now, vectors don't have a position. Like, I can put them anywhere on any space at any time, right? So I'm going to treat the angle measure as if the vector is placed, the initial point, this is the initial, this is terminal, right? Beginning and ending, as if it's at the origin like you see here in the picture. If I rotate around wherever we stop at, and it's obviously just within one rotation, we're not going to spin around more than once. This is going to tell me which direction the angle points at. Now, I'm going to do y divided by x, tangent inverse of y divided by x, right, when you have the component form like this. However, there is a bit of a caution, a bit of a caveat. I have to be careful. If my x coordinate is negative, I have to remember to add 180 degrees. That's not optional. Okay. Now, if I get an angle down in the 4th quadrant, right, if it's down here, I may get a negative answer when I do tangent inverse. That's okay. I can add 360 to it if I don't like it to be negative. I can get that coterminal angle. But if it's over here, if it's in the 2nd or 3rd quadrant, the x coordinate is going to be negative, right? When you go left, it means negative. I'm going to have to add 180 degrees, whatever comes out of tangent inverse. If I don't, I'm going to miss it. Okay? And then one of the easiest things to do is, how do we find a vector from 2 points? Right? We can take x1 and y1, that's the first coordinate, and x2, y2, the second coordinate, and we're just going to subtract. And it's important in the way you subtract. It's the terminal point minus the initial point. You do x's to x's and y's to y's. So we're going to say the vector starts at point 1 and it goes to point 2. So it would be going from this point to this point. So this would be x1, y1. This would be x2, y2 if we wrote it out that way. To get the vector, notice the pointed brackets are vectors. The parentheses are coordinates. Those are points. That's important. I just say terminal point minus initial point for both the x and the y. And the z if we happen to have 3 dimensions. And that's it. Just to illustrate that more technically, you can see that written right here. Here we have our vector written here. We got the vertical and horizontal components on the x and y axis. To find out the actual vector's components, obviously we can take the x coordinates to subtract them, because it would be the difference between these two, and then the difference here would be the y component, right? And here it is again in 3 dimensions. Be careful, do not subtract it the other way around. It's always the terminal point minus the initial. If you do it the other way around, you're going to get what we call an opposite vector, and that would be a vector that's going in the other direction. The magnitude would be the same, but the angle would not be. So in order to kind of do a few new questions, I wanted to kind of just hit a few of these points and kind of make sure we understand all the different parts. Okay, we're going to look at this one here, right? It says given the vector in component form with the initial point 2, -7, 0, and the terminal point 1, -3, -5, let's write a vector, right? From the initial to the terminal. We just kind of got through talking about this. So if I do that, obviously this is my answer. I simply subtract the terminal point minus the initial. You can see that here. 1 minus 2, -3 minus -7, and then, of course, that's plus 7, and then -5 minus 0. I subtracted them, this value minus the ones over here. And this gives me my new vector. Of course, the answer is here. Notice the pointed brackets, not parentheses. Be careful about that. The next question asks, if the vector v, 3, 7, has an initial point of 2, 4, then how do we go to the terminal point? Or what is the terminal point? One of the ways we define vectors is that a vector is a way for you to go from point 1 to point 2. So if I take this original point, that's a starting place, and I use the vector, it's saying go 3 to the right and 7 up. So we literally have two ways of doing this. I can draw it and use a kind of a graphical method. I can go over 3 steps and I can go up 7 steps and I can figure out what coordinate that is. This works especially well if you have graph paper and you can kind of count the dots. That's a little overkill in this example. If I know that I'm starting here and I'm going to be adding 3 to the x and 7 to the y, I can literally do this in an algebraic fashion. I can take the initial point and I can add the vector to that. So 2 plus 3 is 5, 4 plus 7 is 11, and that would get me the same result as if I did it geometrically. Okay. Finding unit vectors. This is actually really, really easy. What you're looking for, we're going to kind of come down here first. Find a unit vector in the same direction as a given vector, right? They're going to give you a way to get a vector. Here you have 2 points. I want a vector AB, so we have to first find the vector, right? So number 1, let's find vector AB. I'm going to subtract 1 minus -2, that's 1 plus 2, and then 5 minus 4 to give me 1. So we have the vector 3, 1. I'd like to have as a unit vector, what that really means is I just want a vector that's exactly 1 unit long. Nothing else. Nothing special there. It's just a vector that's 1 unit long. And so what I can do is, the trick here is using this little formula. Really, if you translate that, it says this. If you had a vector like this, v1 and v2, in order to convert the vector into a unit vector, I'm just going to take the magnitude of the vector and divide it by each component. Okay? So the way we do that is you're going to take the vector in component form, and you're going to find its magnitude like this, right? So we're going to get 3 squared plus 1 squared, which is just 1, which just gives me 10, right? So I'd do 3 over the square root of 10 and 1 over the square root of 10. Technically, that's correct. Now, I could leave it there, but I'll tell you that if you're going to take a multiple choice test, that's not what it's going to look like. It's going to rationalize it. So what we're going to do is we're going to rationalize each of these fractions by multiplying the top and the bottom by the square root of 10. And so we do that, you're going to end up with this 3 square root of 10 over 10 and square root of 10 over 10. And that's a unit vector, right? I wrote MC because this is how the multiple choice is going to look, right? So be careful. I would be okay with this if it's a free response type of question, but if multiple choice type things are like on benchmarks, you're going to want to make sure you do it this way. Okay. In the same thing, if we had it in 3 dimensions, I'm not going to take a whole lot of time to kind of look at this part, but it's exactly the same as before, right? We had 3 coordinates, and that really doesn't change much. It's got an extra element to it. -6, 2, -1. So write it out. Find its magnitude, and then divide by that magnitude, and then rationalize. That's how you would find a unit vector in the direction of this. So what that does is it basically takes the vector you have here, and it shrinks that length of whatever it was originally, and it shrinks it down to a unit of 1. So it's in the same, it's going in the same direction. It's just not as long as it was to start with, or it could be longer if it was a really short one. Okay, Basic applications, this is a lot like physics, and this is a really easy question. This is not meant to be really complicated. They do get more complicated, but for now, we're asking for just components and things like that. Here we have a velocity, which has a direction as well as a speed. So by giving you the speed and the angle measure, I'm essentially telling you the velocity. We have a ball. The moment it leaves the player's hand, it's traveling at 70 feet per second at an angle of 35 degrees. Now, we know that physics comes into play. You've got air friction, you've got gravity. We're going to ignore all of those things for the moment, and we're really not going to go down that path much at all in this class. We leave that for physics. Okay, but the math here says I want to know the moment that they let go of the ball, how fast is it traveling horizontally, and how fast is it going up and down? And you can do that by just finding the components, right? Magnitude times cosine of theta. So it's traveling 57.3 feet per second horizontally, and it's traveling 40.2 feet vertically at that moment that they throw the ball. So the components of this vector, horizontal components and vertical components, would be given just like this. That's the lesson. Hopefully that gets you kind of from yesterday through today. You've got that checkpoint. You're welcome to use your notes on that. Go ahead, give it a shot. That's really for you to see how well you're doing. It is a grade. It's not a lot of points. The more important thing is that you try that and make sure that you understand the different type of questions that we've kind of worked through over the last 2 days. Because if you don't know them, this gives you a chance to kind of fix that and fill in those holes, ask questions tomorrow in class. Let me know if you have any questions. Have a great day.